we are now recording this. One thing you can do with just a guest account is add resources to the system, which means that you can, sorry, someone's texting me. Anything that's not data, basically a video like this we're recording. If you make a little R script, you can load it in. If you make a lesson plan, you can load that in. Anything. So you can just be a guest and do that. You don't have to be. Can I make it larger? Is it not filling up your screen? What are you asking me to make larger? If I do that, is it bigger? That bigger? I can't see what you're seeing, so you guys have to help me out here. Is that helping? It is.
Yes,
Okay.
please. Just make this window larger because I'm not sure that everyone could see the letters.
So that makes it larger. Yes. Okay. Okay, and we'll actually show you this screen in real time too. So there you go. This is the other place to go, right? Where just download records of all types. That's where you're going to get the sort of rich data that I'm about to show you. So this is just sort of a heuristic to show you the kinds of data that are in the PBDB. And the reason this big blue box is so big is that everything in the database is tied to references. So this is mainly data derived from the published literature. So notice all arrows lead from this to the other data types, and others are interlinked with each other. And in fact, they're all interlinked in some way. But there's three sort of categories. So there's the bibliographic, which links to everything. And there's taxonomic names and opinions. So that's pretty straightforward. Names of stuff, the opinions about those names. Over here, there are occurrences, and there are some they're not like, we don't list specimen numbers, but there is a way to enter specimen level data. So that's right over here. In the middle, the brown ones are those that have to do with the geology and geography of the places where the taxonomic names represent occurrences of fossils. So these are the main data types. There's lots of others that are less prominent. I don't want you to think this is complete. You know, and each of these covers many ills. Like taxonomic names are kind of unitary. There's one name. Taxonomic opinions, there could be many, and there's lots of different kinds of data subsumed here. So you can download all that data in different formats and in different styles. And there's, like I said, about 3 different ways to do that, which we'll get to in a sec. And all of this data is tied to the references, right? So you can always download, for any data set, there's an accompanying bibliographic data set that lists all the papers that the data was derived from. And you should almost always download that as well, because we want to give credit to all the people who wrote those papers that you're using. So when you go to publish, you want to publish those references and say, all my data came from this big pile of stuff, rather than saying it came from the database, because the database is just a pile of other people's data. And we don't, sure, we want credit that you got it from the database, but what we really want is for y'all to give credit to the people who collected it in the first place. And this right here is, if you learn one thing today, this is what I want you to learn. You can very finely craft a download to get just the fields you want to get. And I don't like that idea. I much rather download it all and ignore the stuff you don't want to, because as soon as you fail to do that, you might next week decide you wanted this one field you forgot to download, and you've already done a bunch of work on the data, and you'll be sorry. So I'm more of a download it all and sort it out later kind of guy. So that's why I say trust me here. I've done a lot of this. You can ignore that, but you do that at your own peril. I'm going to skip that last slide and start going straight to showing you what we can do in the browser. So let me share my web browser here. Go here. So now can you see my web browser page? Yes. Okay, good. So perhaps I should also say, before I get too deep in here, like what you can do with all this data. You can do all kinds of great stuff. You can plot maps. You can do paleobiogeography, paleodiversity. You can even do sort of historical analyses of the study of your group or a time period or a place. It's really handy for literature searching to use it for data discovery. If you just want to like see what papers are about a given taxon, like I said, it may not be, the data in the database may not be comprehensive for your taxon, but it's a good place to start and see what's out there. And also, of course, you can use this for education. We've written a lot of lesson plans. Pardon me. We have a grant right now to write lesson plans. We've done this at the college level, and there's stuff at the high school level. And so I regularly use this data for my lessons in Vert Paleo. So there you go. Okay, so when you go to the website, paleobiodb.org, and you can see my cursor, correct? No, probably not. Anywho, it doesn't matter. You can, oh good. So this is the splash page that you see. We're also going to get to this one because this webinar is about downloading data, but you can also just go to the Navigator app where it says Explore and do some downloading here. So this is all the data, but let's say I want to get a smaller data set and to pick one at random. I'll pick my favorite, the whales. Here they are. And there's a little summary window down here, 2,588 collections with 4,652 occurrences. So if you want, you can get some statistics about that. So here's this quick and dirty diversity curve. You can go here to get the advanced diversity curve to do ones even more fancy. This is nice for a quick preview. I tend to download stuff. So you can just download this data or download this image, and you get a very, very small data file that has the very basic data to generate this curve. So this is one place you can download data. My only caveat to doing this is that if you were, let's just say, zoom in, I'm zooming in on Europe here. Watch what happens. So these numbers go down because it represents what you see in this window. And if you were to go over here, this curve is going to change because now it's only the data represented in the window. It's really easy to forget when you're doing this that it's only going to show you here and in the download the data that's visible. Okay, so try not to forget that if you're going to use this. And it's one, and I tend to use this interface for data for students, and they forget this. So they zoom in to look at something and they forget to zoom back out to get a global data set. So that's the sort of first and easiest way to get a little bit of data out of the database. So now, since we're doing downloads, let's go here. And this takes you to our download page. And this is a pretty powerful, there's a lot of text here and a lot of radio buttons and a lot of things to fill in. Doesn't look like it, but each of these opens up to show you all kinds of stuff you can fill in. So let's start at the tippy top. There's some text up here about the data service API, which I will talk about after this. But in short, what this page does is it crafts a query to send to this data service to get you the data. And it'll actually show it to you right here in this blue line. So you can watch me build it, and please do. And then the data service has even more fields that you can query on, and there's a whole lot of text about it, and I'll show you where that is. And if you're not getting exactly what you want, you can go there and see if you can add some more parameters to the query to get exactly what you want. So let's start with occurrences. It's the default because it's what a lot of people want to get out of here. And notice that you can get the output in a variety of formats. So comma separated values and tab separated values are the easiest ones if you're going to dump them into Excel, which is what I almost always do. JSON is another one if you're doing programmatic, you want to have a programmatic response to your data, you can use JSON. RIS is for bibliographic data, so notice it's not available unless I click bibliographic data, and then I can pick RIS. And that file can be imported directly into EndNote, into Zotero. So if you want to make a bibliography of the data, let's say I download a bunch of occurrences, I want to go get the bibliographic info so I can dump it into EndNote and thus cite the references in my paper. So just keep that in mind. We'll come back to that. Again, going back here, I always do comma separated values because, you know, I think in spreadsheets. You can show a simpler version of this form. I don't recommend it because then you'll forget. You're like, where is this? And it's going to be on the richer form versus the simple one. So again, Rails are my favorite. And then there's a bunch of stuff here. So I usually work at the genus level. You can work at whatever level you want. And look what just happened. So now this web page is building this query, which is just, it's a web address, but it is a query. Oh yes, thank you, Evan, for putting that there. By all means, I hope you're following along. You can look at your computer while I'm working on mine too, if you like. So I usually do this at the genus level, but notice you can pick other stuff, you can lump, you can split. Here, I usually pick regular taxa only. There are trace fossils of whales, so I'm going to exclude them by picking regular only. And this one's kind of more important. Things in the occurrences get reported as CF or AF or quotes. This genus, I almost always exclude. This excludes all that stuff. AF, CF, question mark, quotation marks, because, you know, I don't know about how you guys feel about your taxa, but, you know, when people put those qualifiers on there, I get very unhappy with their identification. Much less confident. How's that? So you can include or exclude them as you see fit. And if you get into the weeds of the database, you know that we enter every opinion about every taxon, and those opinions change over time. So this lets you do the latest opinion. So there's other ways to make that happen, but for the most part, leave that one as the default. If you wanted to, you could restrict the time. So I'm going to say Holocene, because why not? I'm going to exclude the Eocene, even though it's my favorite. I don't want to belabor this right now, but there's this thing here called the time rule. I could do a whole hour-long seminar on the time rule, and maybe I will. The time rule, if you're interested, hit these little buttons. So these little buttons tell you more about all the options here. So this one's a really good one to read because it's really interesting. You'd think telling whether something was in a given time period or not should be super simple, but it's not. And so we have these 4 different time rules from super strict to super liberal. And the default time rule major is one that seems to balance out the liberalness and strictness of the other ones. So I think that this is the time rule to use, but if you're bored some afternoon, do your favorite taxon and do a series where you download each time rule, basically the same data under the different time rules, and you'll see how different they really are. So counting is important, and this time rule has a significant effect on the counting. Again, so I'm restricting by time. You can even restrict by location. So before I zoomed in on Europe, why don't we do the same? You can make a list of countries, a list of states, a list of counties. Again, we use this model called G-plates to transform the continents and move them around for paleogeography, and you can pick what plates you want to include or exclude, or you can make a bounding box too. You're just a rectangular box on the Earth. So you can here pick environments. So like if I wanted to exclude the few freshwater cetaceans, I could click marine here. If I pick terrestrial, I have a very small download, but there are some out of context, some in context, but freshwater. Again, more stuff where I'm not using specimens, so I'm going to ignore that. You could select by metadata. Like I could pick stuff only entered authorized by me if I wanted. That's me. Don't touch this one. I'll talk about it at some other time. But there is a way to archive your data. When you're like ready to publish, you could make an archive, which we then give you a DOI for. But that's a new feature and it's a little buggy right now, so let's not do that. Oops. What? How's that? If you ever get those red things, that means you did something wrong. It thought I was being ambiguous. So there's only one Ewan in the database, and it's me. But this is really important. Remember I said download all the data you can and ignore it later? That's why I click this button every single time. It's going to give me a large file, but I would hate to, forget to download something and then want it later. So here we go. I'm gonna now look what's happened up here. This is getting a little crazy. This query statement got very long because I selected a lot of parameters down here. So I'm gonna hit download, and then hold on. I'm gonna find my file. And I will now share with you. Okay, can you all see my Excel file now? Excellent. Okay, so this is what a data return looks like. And the file's divided into two parts. And the first part is the metadata. And it's a little summary of what you got. So if you forget what parameters you used, they're all here. I wanted whales. I wanted genera. I only wanted Europe, marine, this time period. So all that stuff is summarized here, along with a summary of the return. So it took 0.214 seconds for the server to respond, and it gave me 879 records. Now, when you're in Excel, the first thing I always do is this. I take that metadata and I cut it out and I put it over here because we don't want to get rid of that. And this is still my data. There. And now I have a proper table of the data, but I did not delete the metadata. I kept it because you probably will want to redo this in the future when you said, oh no, I really only wanted Miocene, or I really do want to include the Eocene. So you can go replicate what you did or alter what you did by looking here to see what you did the first time. So all this data is arrayed, and these are the field names here. So let's just look at one here. Look at this guy. So here's a record for Micromysticetus tobinii, and you can see it's from this collection here. These are unique IDs assigned to the collection and to this occurrence by the database. And we can see that it's from the Chadian, and you can see the reference it came from. Here's the age of that collection. There's a little bit of taxonomy here. It's a mysticeted, so it's a mysticete. And then over here we get the geographic and geologic information. So you can sort all this stuff later. If you have it, you can sort it by rock type. There's the lithology. You can sort them by age. You can sort them by environment. That's over here. So that's why I recommend downloading all this data, because you never know later, what you might want to do with this data. Okay, and so it's really handy to download it and keep it and just ignore it if you're not particularly interested in it right now. So I'm going to just pause for a sec and see if anyone has any questions they want to pop up as I'm going along here, because I know I've been chatting for a while, and I want to make sure that you guys have an opportunity to ask a question if you have one at this point. And you can just use the chat window, and we'll see it and get to it. What is the AK column? Okay. This one? Oh, so yes, the database uses it says CC. That means country code. There are globally accepted standard country codes, and if I had my druthers, I'm not a programmer. Let me just say that. I would be having another column right next to it that says country and translating it for you, because right now you have to go look them up. Perhaps in the next iteration of this, we will add that feature. But right now, that is the country, and you have to look them up. Sorry about that. Does or can this data include specimen numbers, or are the occurrences set for one occurrence for each? Yeah, so it does not. So the database is based on occurrences, not specimens. Now that was an early sort of compromise to get a lot of data in the database early on. There is a way to put some specimen-based data in the database, but it's not fully featured. However, we do have a tool called ePanda, and that's with 2 Ds, so you can Google it, ePanda, but 2 Ds in there. And that tool mashes up PBDB data with data from IDIGBio. Actually, I could do this. Let me share browser. I'm going to go to ePanda. So this was a grant that we had to do just this. And what it does is IDIGBio is an amalgam of museum data, which is specimen-based. And so as long as the museums you're interested in feed their data into IDIGBio, you can do similar queries at ePanda, and you'll get a return with the specimens from the museums and the occurrence data from PBDB, which there's going to be data duplication. But again, if you're trying to cover all this stuff, this is a good way to do it. Yep. Other questions before I continue? Choose archive options is only available if you are logged in. I believe you can do that with a guest account, but again, please don't mess with that. It's not quite ready for prime time, even though we made it live. So Sherry asks, how does PBDB relate to FossilWorks? So FossilWorks gets a daily feed of our data and then does what they do with it. So it should be the same data. There may be a 24-hour time lag, but no guarantees because that's not our website. So FossilWorks does have some other tools that you can use. So check it out. Like there's a really cool strat column analyzer where you can do confidence intervals. That's a tool that I go there to use because we don't have a comparable tool. So yeah, check it out. ePanda looks super cool. I think we had the cutest logo in a long time. I can't take credit for that because I'm not artistic, but yeah, the cute logo is pretty, yeah, I love the logo. Okay, any more before I go back to what I was doing here? Okay, I mean, by all means, pop them up. And you're seeing my browser again, right? Okay, so those are occurrences. Let me show you, let me do a diversity. I'm going to clear all this. I'm just going to reload it, so it'll clear all this stuff. So the diversity return is, I'd say, the most different from all the others because we sort of pre-calculate a bunch of stuff for you. So again, I'm going to use comma separated values. I'm going to do my favorites again. Oops, Isha, Genera, Yoop. Okay. Modifier is going to exclude again. I'm going to do them all this time, so we're not going to restrict based on time. And I'm not going to add any other restrictions. I don't care. I just want them all. And down here, notice there's no options down here. I still got to click it just because why not? And it's because the diversity output has no options. It's just, it always looks the same. So notice again that the downloader has built my API query. And you could actually copy this and paste it into a new browser window, and it'll bring it back for you. I mean, that's what it does when I hit this download button. It'll actually, I don't want to hit that button. Test will put it in a new window for you too. I don't do that very often. So here goes. This is what a diversity return looks like. This one. Okay, so here you can see it looks quite different. So again, we got our metadata up here, and this is the bulk of the return. So these are set to stage level, marine stages for me. And these are the universal IDs in the database for the time periods. You see max, min, these 4 parameters, sampled in bin, implied in bin, and then the number of occurrences. So all these 4 here, these 4 parameters are all identified in this foot paper. It is foot 2000 in paleobiology. So, and I believe the web page shows you where that is. Foot identifies, again, different ways to count. Are they boundary crossers? Are they just in the bin? Are they crossing both boundaries? And that's what these numbers are. So we've pre-calculated them for you. These are ones where we found this fossil, or the Holocene kind of goofy. I don't like the Deleuzine either. Let's look at the Messinian. So there are 43 things that were identified as Cetacea to genus level in the Messinian. Taxa, that is. And so that's what those mean. These are ones that aren't there, but they're on both sides of your time period. So again, these parameters, you've got to look them up in flip to make sure you know what they're all about. But like I said, there's different ways to calculate diversity. And so we just give it all to you and say, go nuts. And you can make diversity plots with these. One thing we don't do is we don't give you a midpoint, but it's easy enough to calculate. I usually plot my diversity plots to the midpoint of the time periods they're in. The other thing to watch out for is that these time periods are in no way even close to being approximately the same length. So sometimes what I do is I'll do a stage level download, and then I'll take all this junk, which is the quaternary, and dump it into one, because if you add them all together, they almost equal the other lengths of the other time periods. So those are just things to think about as you're doing this, And another good thing to do is to look at a paper by someone who's done it before and see what they did and see if what they did works for you. Or if even if it doesn't, you can modify what they did. Okay, I'm just going to pause there again. Any questions about diversity?
Sorry, Mark, we cannot hear you.
Sorry, I muted myself by accident somehow. You can hear me now? So you're just watching me gesticulate wildly. Hold on one sec. Okay, thank you. I did not know I muted myself. I heard a beep and I was like, what was that beep? Okay, so I'm showing you taxa now. Like I said, the stuff down here, some of it changed because it's different for taxa. So in this case, again, I usually work at genera. You know, I could get creative. Let's do species. I never do species. Again, I want just the accepted names. You could also do their synonyms. Remember, we keep track of all that. We keep track of everything every taxon's ever been called. You could look at just the invalid names like that. That's interesting. I've done this. I compared what does this data look like if you use the junky old names versus the updated names, and it's very illustrative to see how much taxonomic practice has altered your picture of these things or not. Again, regular taxa only. I don't know what to really do. And I'm going to exclude uncertain again. And you can add these if you want. You know, I only want the accepted names, which I already said over here, but it's sort of duplicated. And the same sort of parameters down here. I will click this. We get all that rich data, and let's see what that looks like. So again, we get our metadata, time, numbers, and you can see here, we've got all these names of cetaceans, and you can get a little history about them. You can, sometimes we have several names for the same thing. It'll say like the original name and what it's called now. And all of these headings here are defined elsewhere, where I'll show you where you can read what they are in case you're a little confused. So again, we have some really basic data about what they are like as creatures, carnivores. They're actively mobile. Their skeletons made of hydroxyapatite. So you can use those parameters to sort things. And not so much when you have a coherent taxonomic group, but if, let's say, you're doing sort of a fauna, you can say, well, just show me all the stuff made out of calcite, or show me all the stuff made out of aragonite. And that might be a very helpful way to sort things. And this is also very helpful to do this when you're working on the taxonomy of a group to see what's there, what things have been called, and all that sort. Back to the web browser. Finally, I just want to show you what this looks like. And I'm going to do, I'll just do a CSV, and RAS, like I said, is readily importable into your bibliographic software. Okay, so here's what, you know, as you can imagine, every reference has a unique ID. There's the authors, dates, titles, you know, all the sort of basic publication info. Here, just shown in spreadsheet format, we're trying to shift to using DOIs, and I hope in our next iteration of our input software, you'll be able to just put in a DOI and we'll retrieve all this bibliographic info from the web versus you having to type it in. It assumes, of course, that there is a DOI. We have a lot of historical literature in here. All this stuff from back in the day. Where's the dates? Here they are. Pretty old stuff. But the newer stuff that have DOIs, we're trying to populate that field and get it all in here. So again, this is a great way to look at the literature as you're working on a project. Okay, so I'm going to pause there for a sec and just say any questions about the downloader, because I'm about to switch to talking about the DOI. What if stages, geological periods are called different things in different places, North American versus European land mammal ages? Does the output account for that? Yes and no. So we have lots of time periods that you can enter. We don't let you put in anything because the database needs to know about the time period, but we have lots. So we have New Zealand marine stages, European land mammals, North American, lots and lots of time scales. But that's where the counting thing, remember I told you about the time rule, that it becomes important? If you say something's pre-Ebonian and ask for pre-Ebonian stuff, you'll get it. But if you say it's Bortonian, which is a New Zealand marine stage, and you ask for Bartonian, you might not, because they overlap, but not 100%. So the time rule will decide whether your Bortonian thing gets counted into Bartonian over here. So yes, it does account for that, but in ways that you might not expect. And that's why you need to learn the ways of the time rule. And the best thing you can do is try to standardize your input. But basically, when we do input, we ask people to just put in what they got. And the database tries to do some standardization there. Yeah, that's a really good question. Other questions about the downloader. And we will tell you what was entered, and you can figure out how it's being counted. I hope that makes sense. Other question. Okay, so let me show you one more thing.
Maybe you could show in the diversity downloaded file how many occurrences are not counted, where you get that number, how many are counted and others that are not. It's because of this kind of problems with the time.
Yes, so I'm not sure I can show it so easily, but I will say every time I'm like, wait a minute, those numbers don't make a whole lot of sense. I go back and look, and I'm like, and I sort of map it out and count it, and this is why this one's counting, and this one it's always right. I've never found it to be doing it wrong. So there's a question here. You are showing much more information on the taxa than my institution collects on specimens. Is this auto-filled by the DB, or do we need to expand our data before download? I'm not quite sure I understand the question. You mean like it's made of hydroxyapatite and it's a mobile swimmer thing? If that's what you mean, the answer is the DB autofills, because what we do is, so like I said, whales are my thing. So yeah, okay. So I can say cetacea and put in all those ecological parameters for cetacea, and it will populate everything downstream of cetacea. So all cetaceans are actively mobile. But then, I can go in and make exceptions to that, right? If, there are some whales that are terrestrial, so maybe that's not the right place to do it. Or an easy one is carnivore. So for carnivora, someone went in and said carnivora are carnivores. But then we have to go in and be like, oh, pandas, like my pandas, pandas are not. So we can go in at a lower level and say, oh, that's an herbivore. So yeah, it autofills. So you might actually find some that are incorrectly autofilled. But then if you have the power to do data entry, you can go in and then fix it. You can fix it at a lower taxonomic level. So yes, you don't have to know that for every single taxon. Whether they're extinct or extant, when someone enters a taxon, that is a required parameter. So for lots of stuff, because we're fossil people, and lots of the stuff we do is extinct. But every once in a while, I'm up in the Pliocene going, I don't know, and I'll have to just like find out whether a given taxon is extinct or extant. And that becomes important when you're doing diversity, because there's an option when you do diversity to range extant taxa through to the recent. So let's say you had it in the Pliocene, for whatever reason, there was no fossil in the Pleistocene, but it was extant, it'll count it in the Pleistocene as one of those implied in bins. Yep, other questions? I got one more thing I want to show you, and then we'll just toss it open. Okay, so I just wanted to, on that, how I know if fields were autofilled. All of the, we call ecotaf filled. So anything about the ecology or shape of the organisms, like there's a whole block of them that that have that parameter. I just assume anything in those fields are autofilled. Yep. Okay, so this is the API documentation. And remember I said that the download form, I think, lets you manipulate like 80% of the parameters just by pushing buttons and filling in the form. Thanks, Evan, for telling us what the API is. It's an application programming interface. And what the system does is it allows not just you to create these queries, but machines do it all the time. We have apps that access the PBDB. If you've ever used something like Mancos or Rocked or Flyover Country, these are phone apps that actively query the database every time you push a button. And so you can write your own little scripts to query the API. You don't have to sit there with the downloader if you don't want to. I'm not that clever, so I use the downloader. When I can't quite get it to do what I want, I come here and I'm like, oh, where's the parameter to do that? And so this is very information dense. I don't want to go too far into it, but they're grouped. All the different fields are grouped here. These are ones to deal with fossil occurrences. And they're little examples. So all these actually work. And you can change the parameters and see, like, these are all, I didn't do this, but our programmer and I worked together closely. So he used whales as an example in a lot of these. And so most of these are very simple, but down here, you can get all kinds of very rich returns. So again, if you're not quite seeing what you want, definitely look through here, search through here. There's a lot of stuff. Like I said, it's a little dense and sometimes it's a little hard to find what you're looking for, but if it's available from our database, it's covered in here and it'll tell you how to add a little parameter to the API query to get what you want. And what I do, like I said, is I generally start here and then I copy it and then I put it somewhere else. And then you notice that it's just a string. It's like, and rank equals species and taxon status is accepted. So you just put an ampersand and more stuff. So if the parameter you want is not here, you can just put and whatever equals whatever after you consult the very rich data service documentation here. So let me just look at my notes here and make sure I talked about everything I want to talk about. Yep. Okay, so there's just a couple things I want to note, and then I'll open it right up for questions. Is the order of parameters important when altering it? No, he says 90% sure. I'm pretty sure it doesn't matter. It's completely indifferent to the order you put them in. I will check, but I'm pretty sure that's true. Okay, so you cannot download images from Navigator. So if you make a cool map, you have to basically do a screenshot of it. Sorry, maybe in the next iteration we'll make downloadable maps, which would be really cool. We do have a way to get images of fossils, and let me show you how to do that. So, so if you want an image of a fossil, presumably you want to get one for a particular fossil. So I'm going to search for a taxon here, and I'm going to put in my favorite, Dorodon. So it's looking, and it gives you this little data summary page, and tells you, like, here's what we know about Dorodon. And if you want images, ePanda gets them from IDIGBio. So the museums that contribute data to IDIGBio often have images. And so what we're doing now is PBDB is saying, hey, ePanda, does IDIGBio have any images? And then here they are. So let's look at this one. And there's a picture of a skull of Dorodon, which is pretty nifty. And if you're like, well, what is that? You hit this little button and you get the IDIGBio specimen record for this thing. And notice, does it say Dorodon there? It does not. And that's because PBDB is smart and knows that Zeuglodon intermedius is actually a subjective synonym of Dorodon atrox. So it already knows that and did the math for you and found these cool images. So These images, you're like, what's that? Well, this record is an image that was supplied by a museum about Dorodon, and it's tagged with that name, presumably because it's somewhere here. So this is Zeuglodon osiris. So that is been tagged as Dorodon from the Natural History Museum in London. So sometimes you get pictures of newspaper packing material with fossils, but again, those are what are supplied by the museum. So it's kind of cool that you can get images that way. What else is I going to tell you? That's it. That's my whole list. So again, let's just toss it out there for questions. Yeah, if you have one, maybe put it in a chat window, or if I didn't cover something, you're like, well, how do you do this? Now's the time to ask. You can pipe up and turn your microphone on if you really want, because the silence is killing me. Can you search for a taxon by all the names that have ever been known? Yes, yes, you can. So you can search for the old names. Well, like, let me try one. So I'll do Zeuglodon, and up pops its proper name right there. So Zeuglodon is now Basilosaurus, and so it pulled up Basilosaurus when I asked for Zeuglodon. How is the synonymizing of names generally handled? Might be open-ended question, but how does this work for more obscure or controversial groups like musk oxen, for example? Let me show you. So again, I'll go, you know what we're going to do? Zeuglodon. So again, you cannot see this. This is something you only see when you log in, but you can download this. Remember, so you could download taxonomic names and opinions. So this interface I'm showing you, you can't see right now, but you can download all this data. And if you get if you go to the next webinar and you want to become a data enterer or authorizer, you could get to see this interface. So these are all the opinions anyone has ever said about the genus name Zeuglodon. And you can see there's a whole string of them. And in general, well, so what this shows you is the one in force is the one that is in bold. So in general, it takes the most recent opinion, but you can also downweight it. You're like, this is an idiotic opinion. Like, or you can say, well, this one is just repeated from a different source. It's not really a new opinion. So you can sort of parameterize the opinions, but all else being equal, it takes the most recent one, which is what's going on here. And it happens to be mine about this. So there you go. And they're all here. That's what's really great. So if you're actually doing a paper, you know, if the again, caveat emptor, put a little asterisk. If all the data has been entered, then you get all the opinions here. I'm not sure why muskox is controversial, but when it is, it's the data enterers have to make some calls like, you know, it's going to be the most recent one unless someone downweights an opinion and like Evan said, most recent supported by evidence. That's the highest, you know, the most powerful kind of opinion we have is most supported by evidence versus, you know, repeated or implied or, you know, so data enterers do have to make some sort of calls as they enter the data. But like I say, even if it's controversial, we keep them all. And so you don't like the one we got, you can override it when you download. A question regarding connecting platforms. Is there any existing package for PB database in RStudio? Any future plans regarding this? Yes, there is. So let me show you something else cool. So if you go to the main page, remember I was telling you about resources? You can all still see my screen, right? You can see my browser. Yeah, somebody just, one person say that. There's all kinds of stuff. So let's just go to the top, web apps. Navigator's a web app. Matt Clapham did this thing where it does first occurrences. Here's FossilWorks we talked about, other cool stuff. This one was done by a student of mine. It plots diversity versus climate parameters like Delta 18 and Delta C13. Here are some phone apps that I mentioned. Here's all of our lesson plans. They're super cool. So right now, if you're trying to teach some stuff, go ahead and use these. This one's really cool. And down here, there's a bunch of videos. So I will, if this video turns out, post it here. Data entry tutorials. So this is the sort of, if you're going to do data entry, this is the way to go. And there's our R package right there. And if other people create R packages, all you have to have is a guest account to be able to upload this here. So it'll show up on this page so other people can use it, because we want to be all about the data. And so we're encouraging other people to make neat things to share with people that you can do with the data. So excellent question. The R OpenSci is, there's some stuff in there. It could be, there could be more features. And if you don't like it, you can update that package or make a new one. Perhaps you could show the official publications to show how many people are using. Yes, that's a great idea. Thank you. So under here, so there's facts. You can read all about the database, who's doing it. We're hoping to get some more funding right quick. Hopefully, we have several grants in to do new stuff. Paleobotanists, take note. We're putting in for that. And official publications. So if you do download data and write a paper, you can get an official PBDB publication number by clicking that thing and emailing the secretary, who's Matthew Clapham. Do that at the acceptance stage when your paper is accepted, and we give you the number, and you can put it in your paper. So we've had 365 people do that, and this is a great place to see the diversity of things people have done. It's amazing, like stuff I never would have thought to do. Oh, I gotta read that one. Seagrass and cuttlefish. That sounds really interesting. So these are people who've requested the numbers, but if you go here, this is our Google Scholar page. This is all the things that people have mentioned the PBDB in their papers. So Google is sort of doing this, and Matthew is keeping an eye on it to make sure there's not bogus publications in here. And you can see just how many there are. There's God's quantity of them here on all manner of topics. And you can see that the top one ever is the Barnowski et al. 6th Great Mass Extinction paper. Yeah, other questions, please. I see several references are here in press. Can you start entering data in PBDB from a publication once it is in press and not have to wait till it's in print? Well, you can do whatever you want. It's a tough call, right? Because let's say, I work on the whales and I see these sort of papers, once they get a DOI, they're official to a certain extent. And yet, since you can't quite enter the entire bibliographic record, I tend to put those in a little bucket and then wait till they get their proper bibliographic stuff. Or if I can't wait to enter it, because I'm kind of that kind of person, I'll enter it, and then when it comes out, I'll go enter the volume, chapter, or volume page numbers and stuff like that. So what you don't want to do is enter anything in a manuscript form. You want it to have some kind of officialness. So if it's on the most recent papers on the website, go ahead, it's fine. Another thing is I want you to know is if you get to the point where you want to do data entry, don't wait till you're done with your project. What you can do, and this is sort of a pitch to become a data enterer, you can embargo your data for up to 5 years. And so if you're working on a project, you can enter all your field data, the data as you're assembling it, associate it with a mock reference, and then when your paper comes out, just replace the bibliographic info with the actual bibliographic info for the paper that is the publication. And that way, this isn't a chore you do later. It's something you do as you're doing your work to help you, because that you're going to want to analyze this data using the PBDB download. So it's not, this isn't a post-research thing to do. It's a during research thing to do. Yeah. Other questions? With paleo-lat long, what's the point in time that refers to, e.g. the start, middle, or end? that occurrence is linked to, particularly when the plates have moved during the period? That is a very good, very particular question. I think, I have to get back to you. I don't know. I don't know how finely graduated those plate motions are. And if we are doing this, if PBDB is saying, give it to me at this point, it would be the midpoint. But I would look at the G plates metadata and see if we can figure that out. I will ask programmer types and see if I can figure that out for you. But yeah. And just so this is what we're talking about. If you you can do this, and let's say, okay, so they're all of them. You can blow up the time scale by clicking on any time period. And I'm like, well, I'm all about the Oligocene. So here we go. I'm going to do the early Oligocene or the Rhapelian. But this isn't what the world looked like during the Rhapelian. And we use this plate model called G plates to reconstruct the world during that time period. And the question is, well, the Rhapelian lasts for several million years. Where is this reconstruction? And I don't know. For me, it's like, whatever. It's never been a question for me, so I don't want to overspeak to it, but I would bet it's the midpoint, but I'll try to find out. Other questions? Well, I was hoping to go for an hour. We're at an hour and 2 minutes. So I'm going to pat myself on the back for doing a pretty good job. And thank you all for coming. This is just the first of these. We are going to see about the next one being about data entry, for which we're going to have to fix that CAPTCHA. So I'm going to call our programmer what I've done here, and we'll get it taken care of. And yes, thank you all for being here. I really appreciate it. I want you all to stay safe, and I want you to stay busy. So I said, seriously, go out and play with this. It's super fun. You can't hurt it at this stage. Data entry, you almost could. So we'll talk more about that. That one might take 2 hours. So we'll probably be doing that one next week. Keep an eye out for it. Since I have all your email addresses, I will send the announcement to all of you about our next webinar, and we'll do the same thing. I wanted to be sure that if 200 people tried to come in, we didn't overwhelm the system. Looks like we had almost 50 of you, and it did not. So perhaps we'll see about having more people next time. So tell your friends, tell everyone. If you have specific questions, just email me or Evan, and we'll set you up. All right. Thank you all. Take care.